Today's build is a can crusher. This challenge has rules where each group is provided a minimum amount of space to build in with a maximum dropping height of 18 inches, only using a 10-pound weight. We all design and simulate our can crushers on a computer using a program called SketchUp and built it using wood and a 3D printer. But what we choose to do in this minimum space is up to our imaginations. When I went to Google and searched up can crusher, all I got from the images were levers or levers, however you want to pronounce them. I wanted to do something different, something I haven't done before. We all know how levers work. We have the long end, which increases the force to load. We double the distance to double the force, like the nutcracker you see during Christmas. Must be another way to crush cans, right? That's called a fixed pulley. But the movable pulleys are the most important. Two ends of the rope share the load, much like two people helping each other lift an object. Put those together and you get a device that gives you the mechanical advantage of two. Sitting both ends of the rope on a fixed pulley is the same thing. Two movable pulleys will give you the advantage of four, like four people helping each other lift an object. You, of course, being one of the four. Putting these together into reeds will give you two sets of blocks, the same mechanical advantage, just set up differently. It's called a block and tackle, used today in many fields of engineering. Back to designing. On the program SketchUp, I designed my pulleys to fit my bearings, which I took from my skateboard. The minimum size of detail the printer can take is 1mm, and I went below 1mm, which caused me a whole lot of trouble. It's a whole lot of organizing moving pulleys, playing a bit of Lucas Tower, nothing too impressive. Since I designed my grooves less than 1mm, it didn't print properly, so I had to sand down the hairs and plastics inside the grooves, or the hairs would just pop the strings right off the wheels. There's so much mistakes with this one block. When I screwed pieces together, the wood split. It's plywood, it's layers of wood glued together. A way to avoid this is to pre-drill my holes and then screw in my screws later. Well, I tried, but it didn't even spin properly. To reduce friction between the wheels, I printed washers about an inch in diameter. Then I redesigned my pulleys, which turned out 10 times better. Instead of these red-white colorful wheels, I swapped them out for plain white, more functional wheels. Amount of sheaves? Well, I looked at cranes, which had 6, so I put 6. As you can see, when I'm building these blocks, I'm pre-drilling my holes before screwing them together, and this time there were no cracks. Mounting the strings on the pulley system was my least favorite. I had to think of a sliding mechanism to guide my moving pulley, so that it slides down smoothly instead of just falling, like how strings guide a fishing line, but I used bolt nuts with glue.
If you like it, if you don't like it.
My pulleys were just dangling there. Then I thought, what guides a train on its tracks? How do cameras glide so smoothly? How do drawers slide in and out? Rails, of course. But it was still dangling. Simple solution was to straighten those legs. With a bit of adjustments, I got my can crusher completely built like an elevator. We are only allowed 10 pounds of weight.
See the top of your pulley? That's 18 inches.
Come on. This group used a two-armed lever which increased momentum. Converting 10 pounds to 120 pounds was fun. I hope you enjoyed the video, and if you did, hit the like button. If you thought my voice narration was cringeworthy, hit the like button. If you have an amazing idea, go nuts, make it happen. Now's your chance. This is your boy Corduroy, signing out. Peace out.
going crazy.